Recording. All right. Yeah, good morning, good afternoon, everybody. It's good to see you all. So yeah, I'll just give a little bit context about this Snake chat. We all know there was an incident around like 1 or 2 months ago that we had a key AWS key leak. So what impacted us is that we had to kind of recycle our keys to just to prevent like the leak is going to be abused by anybody. So one thing that a couple of engineers we talk about, Dan, Harris, and I, Colin, and just how do we eliminate the use of AWS key in general. And as we know that in Kubernetes, microservice kind of environment, it gets even more complicated because each service, we tend to create a user. So the user has a key for that service. And so very, very quickly that we would have like 20 or 30 user created for all our services. And the issue is that each user has one set of keys. And when we try to do the key recycle after like 3 or 6 months, we will need to go through the whole process again. It could be time consuming at times, and at the same time, it could be like a security risk, something like a key leak could happen again to anybody at any time. So so what another benefit of having fewer keys in Kubernetes is that the key provision could be quite I would say cumbersome in Kubernetes setup. Maybe just can share my screen quickly to show you what I mean here. So so yeah, here I have a little service. It's pretty simple. It doesn't do much. it just go to your S3 bucket, S3 account, and list all the buckets. For this to work, we need to have a key with certain permission, the S3 permission to list buckets. That is no problem. Now we have been doing this kind of thing using this kind of YAML file in Kubernetes. So this YAML file is like a Kubernetes template file to describe your service and do the environment variable injection to your container at the same time. So so just we can see here that this service is going to be called kube2iam demo, and we have the key here. This key is going to be quite important. Don't worry, I'm going to delete this key right after. So yeah, I know it's in the recording, so don't try to abuse it for now. And yeah, so this is going to be used by this service to be able to list all the bucket. So just to show how that works, I can just give a quick demo here, right? So okay, create F deployment. So this thing here. So now we're deploying this service. So we are at the same time we're deploying these credentials to Kubernetes to be used by this MemPy. Oh, you know what? Our cluster needs to be connected to. We need to connect to VPN to be able to do anything interesting with this cluster. It's armed to the teeth. All right, we're connected. Let's try again. All right, cool. So it's the service is being created. To see how they works, we can see. We'll take a look at the deployment status. Okay, containers being created. Okay, logs follow. All right, probably need. All right. All right. So what it does is pretty simple. It print out all the buckets existing in our AWS account. So so this is doing what we wanted to do. That is awesome. Now I can do k delete. All right, so let's delete it and go back to where we were here. So as you can see, these kind of credentials, we need to have them either in this YAML file in the deployment, or more conventionally, we have a standard of doing that. We put them into a secret template and refer to that template. So meaning that we will have two YAML files. One is the service description, and another is like, what kind of secrets this service need. So we create two files, and we refer them together. So refer to each other. So they could be extra step, during the deployment. And of course, the keys in either in this file or in another secret file is just an additional risk. So what we want to do is for this talk is, can we try to not use key at all? Just keyless. Like, the keyless call are way more, attractive than the key. The call unique keys. So to do that, we use kube2iam. Kube2iam has a very interesting functionality. You take advantage of the AWS roles, meaning that in this cluster, we have a role in this cluster that is being used by Kubernetes, and this role can assume any other roles. Just if you give the permission, this role A can assume any other roles in role B, and role B could do interesting things like having access to S3 or reading from SQS. So demonstration, and I'm going to try to create a role called kube2iam demo, and they're just gonna give permission to this role and use the role to access a bucket without needing the key at all. So to do that, we need to create a role very quickly, and here's how I do it. This is the AWS CLI, so just say create role, kube2iam, this and that, and in here I have a policy file. It is a required thing for creating a role. So this is quite simple. It just says like, okay, this role I'm going to create to access S3 bucket for my service kube2iam demo. It can be assumed by this role in Kubernetes. This is the cluster role. So cluster role can assume any role with a certain permission that our service need. So this is something we can just copy and paste, and just this is generic, So for each of the service, like Harrison has service A, Dan has service B, they can just use this thing. This is perpetual for this cluster. So let's just try that very quickly and see what happens. So let's do this. All right, a role is being created called kube2iam demo, and we could see that from our AWS console. Oh, come on. Let me refresh and hope that works. Suspension. Oh, all right. So we got this. Okay, this role is particularly this is going to be used by our service, the just listing bucket service, and the trusted relationship in here. We could see that is already created for cluster role to assume this one. So the only thing we need is to give this role a proper permissions to access S3 bucket, and that will be all. So so what we do here, we can just attach a policy to it, and we say S3 for access. And if we do that, this role now has the right permission to do what we want to do for the service, and it's called kube2iam demo. Then what do we need to do here? It's quite simple. We don't need a key anymore. Like compared to this one, we would have the key for the environment variables. And now we don't need that. So this saves us some extra steps of creating another secret file or create another user. But still, you need to create roles, but create another user, generate keys, manage the keys. The key's gonna get expired, the key's gonna get leaked. Just more trouble in there. But one thing this one needs here is to add an annotation to say, okay, this service is going to use IAM AWS role, this role. So instead of having keys in our YAML file, we just need two extra lines of annotation. Then we're pretty much all set. And I'm going to test this right now. And while this service is going to get started, I'm going to pause a moment to take any questions.
Stephen, how does it assume the role? Like, is there the kube2iam service running somewhere?
Spot on. Okay.
is that coming up later in this demo?
Okay. This is a good question. This is the details I was asking for the questions instead of like just showing to you. So let's get all the K and S. I think it's in the default. So I'm changing myself to the default namespace, and let's try again to see if we can see this daemon set. All right. So yes, there's a daemon set running to each node on each node that is going to do the translation from row to row. So it's so this is called kube2iam. So this one has to be deployed to the cluster. And another thing that I know you're quite curious about this, so I'm going to give you the full package, paint you the full picture here. So go away. Okay. So having this role created is, yes, you're right, the part of a story, but it is a story that most of us need to worry about. But because this detail is being hidden away from you, it's like, to assume the role, we need to give the cluster role the permission to assume any other roles that is prefixed with not prefix, but then under this K8S role. So this is the little structure I've created. So instead of like assuming all the roles, only the KS role, just to kind of like have more structure around things. And as you can see here, this role is K8S kube2iam, meaning that the cluster is now like able to assume anything that is under this particular path in ARM. So when we do this, we just need to copy this command here in the README file that just create a role and having the path K8S and assume the role, letting the Kubernetes the cluster role to be able to assume that. Does that answer your question, Dan?
Yeah. Is there? I guess I could continue asking, but I'll hold off from there, and maybe I'll ask later on because you started the container already, right?
Yeah. So it's probably started already. Let's take a look. Huh. Are we still good? Not sure. Oh, okay. Ah! Okay, sorry for a little bit debugging session here. So basically, it says my my pod crashed. Oh no, it's No, it's a job thing. So you crash right after, the job is completed. Phew. Yeah, you can see like okay, so this service not needing the key is doing what we wanted to do. So this is so cool here. Yep. Yeah, it's pretty much the demo. And yeah, I'll be putting this up soon. Maybe put that into I don't know, into one repo. We should have like a Snapchat repo. I don't know, just to submit all the source code. I don't know, materials. But yeah, I'll be putting this up on paper. With all the commands and all the YAML file we need to get the service running with kube2iam. So actually, the only thing we need to worry about is to create a role, give the role a permission, and use it, with annotation. All the things like assume the role, and also like having the kube2iam configure and the setup in the cluster, it's all done for you. So just there's no need to worry about that. Yeah, any questions so far?
I had a question about how it limits the like which cluster can actually use the roles. I think it was something that might have been in the AWS dashboard. But how did you specify that the US East cluster had access, or how did you limit it to just that US East cluster?
Okay, yeah, this is a good question. This is being specifying here. This role, this is the S3 bucket, the role we just created for kube2iam. There's a trust relationship saying something like, only this role can assume me. Other people cannot assume me. And this role is only used for the US East cluster. It's not even like Stephen cluster, not even the Harrison cluster, just the product US East cluster here. And this cluster says, okay, I am going to be able only to assume the rules, after this pass. Does that answer your question so far?
Yeah, I guess the only thing there is like, how did this part get created? Was this something that you had to do manually first? Because like I'm wondering if we have another cluster, how would we hook that up?
Good question. This part is created manually. If we have another cluster called kts dash I don't know x, then the cluster is going to have its own roles. It's going to not this one, and we will need to go to the cluster role and create a kube2iam permission to assume any roles after under this whatever path we wanted to be. So so right now we can pretty much not use these two things. So now we can see like this is the issue that we are having, or we have been having, is that we either use keys or we attach a lot of permissions to this cluster. So this cluster has like all the permission, all the services ever needed for then this can grow a lot, and then not having the departmentalization between each different services. So so this is going to be able to help us a lot on that level.
This is cool.
Stephen, so from what I remember with kube2iam, because you're not passing the key, the AWS library, what is that? The Bono library or whatever? That is that what you're using? That uses the standard AWS like metadata endpoint, right?
Yeah.
Is that how? Because it uses the Bono, the S3 client. So to get the credentials, it hits the metadata endpoint, right? Is that what it does? And then that returns keys to perform the action.
Yeah.
Right. And it assumes, and it. What I'm curious about is how does the kube2iam daemon set come into this? Like, does that intercept that request to the metadata endpoint? Does that does that service, how does it use the annotation on your deployment YAML file to ensure that that container is getting the right thing. So I don't know if it intercepts networking or like what does it do. I'm curious about how that part works and where that kube2iam
and I also
data set
wanted the
comes in.
question, so I'm totally okay if you
Yep. Okay. That is a good question. So I think I only have 50% of understanding to this magic. So I'm gonna admit that upfront. So what I think is happening is that once we create this daemon set in the cluster, because from the kube2iam, it has to apply a certain IP table to block the accessing metadata to the node. The thing that we had, we had this vulnerability before. Remember, like you're able to access your metadata or for your IAM role in your EC2 cluster. So my assumption, my guess is that kube2iam has a daemon set to kind of return the metadata to each individual pod, pod, and at the same time try to block. They try to create a new IP table for each node to not be able to access this metadata. So this is how I think it works. Having an annotation talk to the kube2iam, tells the pod to talk to kube2iam, and for the particular role. And yeah, the rest of it is a blur to me.
So do you have like, I don't know if it's just on the kube2iam repo or something, like what the changes to the IP table are? Like I'm just curious what it looks like, what that change for like the kube2iam install looks like.
Yep, that's a good one. So the IP table has been. Sorry, Dan. I think he was trying to say something, but it got delayed.
Oh no, I just muted myself.
Okay. So yeah, so the kube2iam, the IP table creation is done automatically for you by the kube2iam. So it has something like that, you just need to find the right interface. In this case, we use a CNI0 with Phenomenal for production. So this is where the magic is. I'm gonna include that to our chat here, so everybody can take a look. Yeah, and this daemon set here just leverage the IP table, and yeah, I mean this is all like magic to me. I just trust it works. Yeah.
So, oh, go ahead. I was just going to say, it looks like, sorry, no, Harrison was going to ask something. It looks like it updates the IP table to intercept that metadata endpoint, which is that IP address. And then it takes the port 80 requests and then forward it to the Docker, the Docker runtime, the Docker networking interface on each kind of, each node, which is where the containers run on each one of those because it's a daemon set. And then when it forwards it to port 8181, which is where this is running.
Yep.
So then, and then the host IP, I guess there's probably like digging into the source code and everything, but I think I understand. So it basically uses the IP table to intercept the request to port 80 and forward it to kube2iam as the proxy to that thing. And then that probably checks the annotation.
In terms of the right.
Yeah.
Got it. Got it. Thank you.
It's a sneaky proxy.
It is.
It's cool though. I like it. I just had a question. I'm just thinking ahead about like some of the stuff that we're playing around with Istio. I wonder if there's a way that we can run this as not a daemon set and just put it as another like node on the service mesh. Like I wonder if there's anybody doing that. Like have you looked into that, running this in any other way than a daemon set yet?
No, I've not.
Okay.
Yeah, have not. You let me try to understand this a little bit better. Are you trying to say like let's not do this as a daemon set. Let's like something lighter? And is that what you are asking?
I guess what I was thinking is like, I wonder if there's a way, like, yeah, I'm sure there is, but a daemon set just kind of describes where that, like, we're going to spin up one of these for each of the nodes. Like, that's probably fine. But the other way would be to maybe just run this as one or a couple of, like a standard deployment. And because the service mesh principles just allow you to talk directly to that thing, and they don't really care which node they're on. But either way, if we have to run it as a daemon set, we're probably okay, because we could put like an egress rule with that. We know the IP address that it's sneaky proxying on, so we could probably just open up that one thing. But I don't know. I was just curious if you'd played around with deploying this in any other way.
No. Yeah.
I think it's interesting. It could be an option, Harrison. I'm just not sure what the IP table would look like, because I think what we're running this as privileged on each node. This has access to like run like on the kind of root level, I think.
That means
so
we will need to start.
I think that's one of the principles why this exists, or like why this works with IP tables. If we could do something with an IP table to say, like, instead of sending it to the Docker 0, I think if you scroll up, it has like, what is that on the IP table configuration, like Docker, in interface Docker 0, and I believe it takes that like to destination metadata. So I think that, it must be proxied for Docker containers. So basically it's saying that like proxy all traffic to Docker on the destination, curls it on port 8181. So I think that should allow it. This is interesting.
Yeah, this is the metadata API endpoint.
So this is interesting. And the destination is running curl at runtime, which grabs that machine's IP address. And then on 8081, so each daemon set container is running privileged. So it's accessible on each machine running 8081. So if you SSH onto any one of these things and just curl localhost 8081 or whatever it was, you would, or whatever that machine's IP address was in the cluster, it would grab that and intercept that request. So I think it would have to be something like that, Harrison, like right here to somehow say that to destination would have to somehow interact with like a networking layer that was like maybe like running up the machines.
What we can do is like just continue.
If we were using the Istio stuff, that proxy is already sitting there in front of it. It's using an Envoy proxy. We could just point it at this, is what I was thinking. This might actually, we might be able to run this without having to make it privileged, which would be ideal, I think. Not that it's bad, but people are doing this, but like it would be more secure, I guess.
Does the Envoy proxy give us a local IP address on the cluster?
It does it, and also probably other options.
That's definitely interesting, because I think that's that definitely could work. For this, I mean, I love the simplicity also of this right now. It's like each machine, because each machine has a metadata endpoint that kind of just intercepts that traffic on a per machine basis, which is super slick. And it's just kind of independent of any other kind of dependency. Like it's just only dependent on itself and its IP table, which is pretty slick. But
one thing I'm particularly interested about is that we all know this endpoint is to access like your AWS key and the secret for the particular node, and it is easy. But then to get this, we will probably get the role for the cluster, right? But how does that annotation maps from the cluster to the role that we are going to assume? It's something that I haven't quite figured out. How does that know? Yeah, you get a key. It's cluster key. That's it.
Cool.
Say that again, Stephen. Like, how does that?
Well, okay, this one will get the AWS credentials for this particular cluster role, and I'm just curious, how does kube2iam can from the cluster role can get to the service role, like the kube2iam demo role? How where is the mapping coming from?
So there's a metadata endpoint. I've seen it once. I don't know where it is, but it's like 169.254 blah blah blah, and then it says metadata, and there's an endpoint called like assume-role, and you can curl that endpoint from any machine and tell it what role you're assuming, and then it will say, okay, now I'm assuming this role for the next request, or it'll give you like some sort of key or something. So that allows. So basically, I think if you probably like search this repo, there's probably like assume-role somewhere in the code base where it's like, I think it's proxying that request. Like you're saying, give me the AWS key for my role, and then this thing intercepts that request, looks back at the container, finds the annotation, says, where's this request coming from? Let me look at this annotation on this container. I think that's also why it runs as privileged, so it can like look at the Docker daemon and understand where the request is coming from. And then it's the assume role endpoint, assumes that role, calls to get the token, and then returns the token to that pod. So like the proxy step does like looks the container and then calls that metadata endpoint on its own to assume a different role.
Okay.
I believe that's how it works.
Yeah,
or
that
maybe
makes sense. So the node, this kube2iam daemon set basically has a role to has a permission to list all the roles that cluster role can assume, and map that to the annotation and use that for the container.
Yeah, like I think if you put an annotation that was an incorrect role, that original like startup script would fail to get anything because it didn't have a correct role maybe, or something that it could assume. So it would probably pass back a failure to like getting AWS keys, so your service wouldn't start up. This is awesome.
Right now, we have two services running using this one. The log collector is already using this. So the log collector is keyless, and I think Eric is also having one service using that, and he mentioned that for the update worker, the column is doing right now. It's going to be using this strategy, this approach as well.
That's awesome. Does anybody else have any questions on this? I know it's like there's like a lot to take in. I didn't even know that like the metadata endpoint existed for a while. I was like, what? There's like a way to do this? Like, how does this work? And there's so many like weird AWS.
Yeah. Then remember like 2 months ago, the guy Oliver Fish. Yeah, he exposed a vulnerability to us. Like he was able to see our role credentials using this endpoint. So it was a wake up call. And then the little did I know at the time that we will be using that for kube2iam. It's good learning. Cool. So no more questions. Then.
Do you think this is solid? Like, do you want to continue moving? Like, what's your experience so far? Has it been good? Do you think we should use this more to replace the AWS keys in our cluster?
Yeah. Right now, like I said, like 50% are still magic to me, and I would really love to get more familiarity to this before we move forward with more important services. So I would say like I'll keep continuing using that, and at the same time see how this developed and try to understand the magic behind it before we can more confidently put more service, using that. And So this is not like I think this thing is not from a particular company. It's a one-person contributor Yeah, with this kind of open source project, I just want to see more track record of that being used. It's just my personal opinion, though. Yeah. So I think that right now it's safely to say, like, right now we're still evaluating, but this is so far I think it is quite interesting. But I think I just need a little bit more confidence with this before like putting important service on there.
That sounds good to me.
Cool. All right. Thanks everybody for taking time today. And I'll put the recording up right after and delete my keys. I'll catch you all. Thank you.
Bye.
Bye.